Hello, my friends of Catray Labs. Please welcome to this tutorial. This tutorial is for the simulation of an infrastructure tunnel with Tupac Cloud. So we are going to start with the tutorial. You can sign up with your Hatari Labs account. So here I have my Hatari Lab account, Hatari Lab email. Okay, great. Okay, and the freemium license has only allows you to do just 3 models. So in my case, I have to delete the previous one in order to create a new model that is going to be called infrastructure tunnel. And this will be the simulation of a tunnel. It will be meter seconds. And the EPSG code is 32718. And we are going to model from the 2001. And then here, upload. Okay, so this is the one that I have. Okay, I'm going to, so it will be, because I have a background, how say, draft. So it will be infrastructure tunnel, doesn't matter. So second meters 3, and this is will be from 2008, 2001. Okay, so now we go to edit. We have to add a mesh limit. This is always a polygon. So we select, and then you are going to receive on the description of this video a link, the link where you can download this data. So this infrastructure tunnel. Okay, so and this is a zipped shape file. So this is model limit 2.shape file. We upload that. We will have just two refinement layers because we will have the drains of the tunnel and the river network. So here we have drains by elevation, and the drains elevation, this will simulate the tunnel. So I say tunnel yearly.zip, and the drains by depth, that will simulate the string. The drains by depth will simulate the stream network. So this will be river network. Okay, okay. Because on the drains by elevation we specify the elevation um, of the object, while in the drains by depth we specify the distance from model top. Save layer. Okay, we create the mesh. We create the mesh. Okay, and that's it. Beautiful mesh, really smooth. You can take it, you can take out the grid if you want. Then you can put another background. Okay, great. And then these are the, well, actually it's with, these are the point cloud. Okay, so we generated cell 2D, and then we continue. We define the model top. The model top will be a DEM file, and we are going to work with 4. I think that is 4. We are going to work with 4. Yeah, we are going to work with 4 layers. So we update that. And then we wait because there is a tree view of the layers. This is of the model top. Okay, in the coming versions, this will be clipped to the extension of the mesh, of the model mesh. Okay, and then we do continue. And then we select the bottom of layer 1, the bottom of layer 2, the bottom of layer 3, the bottom of layer 4. Then we do save, and then we also wait because there is also a 3D representation of the imported elevation models. Okay, There is some not an some values, some empty values at the corners of them that doesn't allow us to see doesn't allow us to see with better definition the different layers. Okay, we are going to work on that. Okay, so we do continue. In this case, we are going to work with I think that those are how many? Let me check. We are going to work with 5 stress periods, and on the freemium you can the maximum number of stress periods is 5 on the freemium license. Okay, and this will be from 12 no 31 12 2000 00 to 01 01 2001 00, and this will be one time step, and this will be unsteady, and this is from 0101 2001 00 0104 2001 00, and this will be 1 1, and this will be transient 0104 2001 00 0107 2001 00 1 transient 0107 2001 00 0110 2001 0041 transient 0110 2001 00 0101 2002 0041 transient. Okay, so that's it. Upload on the steady on the, let's see, the hydraulic conductivities. That will be 0.004. That will be convertible. They will be 5 and 10 to the minus 7. That is also convertible, just type C, and it will change it to convertible 1 10 to the minus 7. Confined 5 10 to the minus 8. Confined. Okay, save. And the transient one, the specific storage 1 10 to the minus 6. The specific yield 0.15. The initial conditions we set up as the model top. The solver, no big changes. I mean, we have not introduced wells. We are working with drains, so let's work with the drains by elevation. Okay, so here on the drains by elevation, this is the infrastructure tunnel that actually starts with this from 0, 1, 2, 3. So the elevation is 3,800. In the first stress period is not active, so with the conductivity 0. And in the second is active, and it remained active on the next one, on the next stress periods, because like it's draining all water that can reach the drain on the for 1 year. Okay, let's go to the second one. The one is not active on the first, neither on the second, but from the third stress period is active. Okay. And so for the Okay, and the third one is active from the 4 stress period. And the final one is active on the latest stress period. Okay, upload. Okay, so we have defined our drains by elevation that represents the infrastructure tunnel, while then we define our drains by depth that represents our river network. So this is our river network. Actually, if you see that, this is our river network. And here the depth is 0 because it's at model. This is depth from model top. This is depth from model top 0.001. Okay, 0.0001 and then upload. Okay, so this is, we have already the drains, we have already, now we have to define the recharge file and then we apply recharge to the whole extension of the model. So we are going to use the model area of the model limit. Yes. Okay, here we use the model limit and the recharge rate will be 3.8 10 to the minus 9 for all the stress periods. Okay, great. And as well for the let's define the evapotranspiration file. The evapotranspiration file will be model limit as well. Okay, and the evapotranspiration rates will be 3.8, 3.8, 10 to the minus 8, 3.8 to the minus 8. 0.5, the routing depth, upload. Okay, so now we have, what we have is drains, recharge, and elevation. So we can run our model. So we can run the model here, generate and run. Okay. Okay, and now it has created the floppy package, and now it has run the model. And okay, and then we have a problem here that interesting. It has a converger, but it only works with one time step. So, but I say, and I think that I remember maybe here on the temporal schedule. Ah, okay. I missed this. The multiplier here is 1, sorry. And this is 4. 4 and 4. Okay, so the mistake was that we inserted a multiplier, but we haven't inserted the time step. So this is the time step. So we update that and then we run again. This thing could happen. Okay, so there are several processes that are happening here that is doing the merge, is doing the, well, okay, so here we see, okay, now it has run 4 time step per stress period. There is a one converse failure, okay. However, like, and I think that, yeah, it's on the steady state. Well, we can fix that something out. With the main inflow is the recharge, okay, and the main outflow is the drains. This is the initial state where you only have the drainage network, and then with the tunnel, actually you got more water to the drains, and evaporation is also a main, well, is around 10 times bigger discharge than the drains. Okay, so and it's on the steady state, the stress period with the higher discrepancy. But let's see the head distribution for, let's see, for the final on the drain on the grid. Since this is has the difference in elevation are huge. For example, for the first layer, we don't see that much, neither as contour nor as grid. Okay, but if we go to the second layer, we see some heads here. But if we go to the third layer, okay, here we see the impact of our drainage tunnel, I mean the infrastructure tunnel, how is affecting the, I mean mostly it's taking water from this part. Okay, the water that was in the normal way to this part is being intersected by the tunnel. This is for the final, but let's see for the third stress period, for no, for the fourth stress period, it's like this because the tunnel is the progressive of the tunnel is in this direction, and then as well as at them. And then here on water table, we can also see the water table. Okay, this is the water table, and this is for the third stress period. And then we see that the head is three. Well, the head of the tunnel is 3,800, and this contour is 3,817. Okay, and then we can do a cross section. Where we do the cross section, we are going to do the cross section from here to here. Let's see, from the 4 stress period with the grid. Then we just plot it. And okay, so this is the tunnel. This is 3,800, and this is the other stress period, the other river network. Okay, very interesting, as we can see here. Okay, so think that the I think that this I think that this tutorial was really interesting in order to describe fracture tunnel, transient models, and then mostly how can you treat or how can you work so easy or in a really smooth way when you are using Tupac Cloud. Thank you for following us. Please share with your colleagues and friends. Subscribe and see you in another tutorial. Have a great day. Bye bye. Bye.